limits worksheet, so let's work through this. Refer to the graph right here to evaluate the following. The limit as x approaches 0 from the right f of x. So remember, this right here means from the right, the little plus sign means from the right. So we gotta go to 0. Here's 0. It's the little dotted line. And I want to approach this as you come from the right, so as you come from this side. So all we do is look at our graph. So you start anywhere you want, and you come from the right, and you just gotta follow it all the way until you get to 0. Now going from all the way down here takes forever. Just get close, like around here. We're gonna go towards 0. So follow, and if you follow the graph, it's going to positive infinity, or just infinity. So there you go. Next one, limit as x approaches 0 from the left. Remember, the 0 means the little minus sign means from the left. Now what you gotta do, same idea. We're trying to get towards 0 right here, and we're going from this direction. So just follow your graph. As you go from the left, as you get closer to 0, you're going down to negative infinity. And now I want to know what the limit as x approaches 0 is of f of x, if this is a function. So now all you have to do for this one is check these two. If these match, that's your limit. If they don't match, the limit does not exist. As you can see here, one's going this way, and one's going this way. So the limit does not exist. Next one, same idea, but as we're getting close to 2. So we want to get close to 2. So 2 would be right here. Same idea, I'm going to do a little dotted line so you can see what we're talking about. And then the first one says, oops, sorry, 2 from the right, right? So here's 2, we're coming from the right. So again, I'll go this far, just follow your graph. Where's it going? It's going to about 2. 1, 2. And then the limit as x approaches 2 from the left, a little minus sign from the left. So here's 2, we're coming from the left this time. So let's follow this. Now remember, we're going closer to 2. So we're going this way. So following the graph, you go to 0.5 or 1/2. Again, these do not match, so my limit does not exist. As you can see here, like they're not going. The one's going to here, one's going to the limit. They have to go to the same spot, so the limit does not exist. Next one. Now we're talking about 7. So I use 7, 3, 4, 5, 6, 7. So right here. So the dotted line again. So limit. What's the limit of f(x) as x approaches 7 from the right? So we're going from the right. So again, it means that we're coming from the right hand side. So we're coming from this side. Where's our graph going? It's going to -1. Now remember, it's where it's going, where it looks like it's going. I don't care about the solid dot, doesn't matter to me. What does it look like it's doing? Oops. There you go. And it looks like it's going to -1. Now limit as x approaches 7 from the left. So we're going this way. So we're following the graph this way. And as we get close to 7, looks like we're going -1 again. And then those two match. So my limit as x approaches 7 is just -1. Right? Limit from the left, limit from the right, both -1. Remember, the limit doesn't care about what happens at the point. That's like the value. The limit cares what it looks like it's happening. And it looks like we're both going -1. Okay, 11. So 7, 8, 9, 10, 11's over here. 8, 9, 10. So, dotted line. Now limit as x approaches 1 from the right. Now there's no right hand side. There's no limit here. There's no right hand side. So that's no solution. It's a bad question. Limit as x approaches 11 from the left. Well, from the left. Right, if you're going from the left, you follow the graph. It's going to 1, 2, 3. So that's 3. And then the limit as x approaches x equals 11, well, these don't match. One's no solution, one's 3. So this does not exist. The limit does not exist right there. There's a one-sided limit that exists, limit from the left. But there's no right-sided limit, so limit does not exist. Next one is 4. Same question, but at 4. Let me change the color. So 3 here is 4. Hopefully by now you can just see what the limit's going to be. Right? If I look at the limit from the right, it's going to be 0. Limit from the left, it's going to be 0. So it's going to be 0. That wasn't the question, though. The question was, what's the limit as x approaches 4? Well, 0. Both sides are going to 0. Next question, what's the limit as x approaches 5? So 5 is right here. Same idea. So let's go to this point from the left and from the right. From the left, you get -1. From the right, you get -1. So that's my limit. Both sides match. F of 0. So remember, f of 0 means what's the value at 0? Like, what's the closed circle at 0? Well, 0 is nothing. It's like asymptote, so no solution. F of 2. What's the value at 2? Well, here's 2. Remember, value means you want the closed circle, so that would be also 2. So it'll be that value right there. F of 4. So here's 4. I don't see a closed circle anywhere. It's an open circle, so no value at 4. F of 7. Now, f of 7 is a closed circle, which makes that 2. So the answer there is 2. So next question. True or false? The limit f of x exists for every c in the interval from 2 to 10. So they're just saying that every value between 2 and 10 has a limit. So let's look at here. Let me erase some of this. We don't need. So they're saying from 2 to 10. So 2 is right here, and 10 is right here. So all we're looking at is between these two things. Is every value have a limit? So limit exists. Limit exists. There's limit right there. Limit exists. Limit exists. Limit does exist right there. Right? Remember, it's not that. It's down there. Yeah, every value between here and here has a limit. Between those two values, everything has a limit. So that is true. Next one, true or false? Exact same question, but between -2 and 2. So between -2 and 2, let me erase this. Between -2 and 2. So we're looking like in this little section right here. Alright, I'll just color that in real quick. So in here, does every value between here and here have a limit? Yeah, then no. 0. Right? There's no limit at 0. Everything between here has a value. Everything between here and here has a value. But at 0 there's no value, there's no limit because they go different spots. That's different than like right here. But there's no value, but from the left side and right side, you're both going to the exact same point, so the limit is 0. At 0, a little confusing, I know, I'm sorry. This one's going negative, this one's going positive, so they're not going to the same spot. So limit does not exist at 0. So this would be a false statement. Okay, let's move on. Find the limit of the following. Remember, the number one rule for limits is sub it in. If it works, you're done. That's your limit. So plug this in. I get 7 times 1 squared minus 3 times 1 minus 2. So I get 7. This goes first. 1 times 7 is 7. Minus 3 minus 2. So I just get 2. Boom. There's your limit. That's all it is. Plug it in and see if it works. The next one. Right? I'm going to plug in 6. So I get 6 minus 6. Already there's some issues. 6 squared minus 4 times 6 minus 12. 36 minus 24 minus 12. I get 0 over 0. 6 minus 6, 0. 36 minus 36, 0. So the number one rule of limits, remember, is plug it in. If it works, you're done. If it doesn't work, there's different things. So in this scenario, I get 0 over 0. That means you have more work to do. And for this class, the only way we know how to fix it right now is to factor. So we got to factor this. So limit as x approaches 6 of x minus 6 over, I need two things that multiply to get negative 12, but add to get 4. So that's x minus 6 and x plus 2. Trick there, I knew it had to be an x minus 6 so they could cancel out. Now you're left with limit as x approaches 6 of 1 over x plus 2. So now we just plug in our 6. And I get 1 over 6 plus 2, which is 8. And that's my limit. So that's a graph with a hole in it, and then you had to figure out what the limit was. So that's all it is. So the general limit is 1, plug it in. If it works, you're done. If you get 0 over 0, that means it doesn't work, and then you have to solve it. You have to fix it. Our only really way of fixing it right now is to factor. Next one. Limit as x approaches negative 6. So plug it in. So I get negative 6 minus 6 over negative 6 squared plus 36. Well, I get negative 12 over 36, 72. That's my answer. It's a number. Done. Next one. Limit as k equals to 4 of k. So remember, all you do is plug it in. And I get 4. Done. Easiest one. Next one. limit as r approaches 3. So let's plug our 3 in to both of them. So you get 3 squared minus 9, 3 squared plus 9. I get 0 on top, minus 9. On the bottom though, I don't get a 0. I actually get 18. This does not mean more work. You are done. 0 over 18 is just 0. So my answer here is this 0. That's totally fine. 0 on top is okay. 0, when you get both 0 on top and bottom at the same time, that's when you do more work. So that answer is just 0. Next one, plug in 3. And I get, let's see, 2 times 3 squared minus 5 times 3 minus 3 over 3 minus 3. So this is squared. So 0, this is 9 times 2, 18, minus 15 minus 3. So I get 18 minus 18, that's a 0. So this one I get 0 over 0. So I got to factor it. And that's a little tougher, there's a number in front. So let me erase, I need some space. 0. Let's multiply the first term and the last term. So I get negative 6x squared. I need two things to multiply to get negative 6, but I have to get negative 5. That would be negative 6 and positive 1x. So I get, or I'm going to replace that with this. Or I'm going to replace this guy with this guy. It's a. Then you factor by grouping. These have a 2x in common, x minus 3. Factor out of 1. That's all they have in common. These match. So I get x minus 3, 2x plus 1. Right, so that's its factored. Now that it's all factored, go back here and rewrite it. This is x minus 3, 2x minus 1 over x minus 3. I shouldn't forget the limit as x approaches 3. So right, I plugged in, I got 0 over 0, and now I had to fix it, so I factor the top. Now these cancel out, and I get the limit as x approaches 3 of 2x minus 1. And now it's an easy problem, now you just plug it in. 2 times 3 minus 1, so 6 minus 1 is 5. That's my answer there. So I got a couple more problems to do this. Plug in 2 squared minus 4 over 2 squared minus 5 times 2 plus 6. So 4 minus 4, 4 minus 10 plus 6, I get 0 over 0 again. So I got to factor it. Look, this is an easier one to factor. The top is the difference of two squares, right? So I get x minus, let me do x as x approaches 2. X minus 2, x plus 2. The bottom, I need two things to multiply to get 6, but add to get negative 5. So x minus 2, x minus 3. Right, they're both negative because of positive, but they're all, and that's a negative. And then look what happens. These cancel out. The limit as x approaches 2 of x plus 2 over x minus 3. Now we just plug in our 2. And I get 4 over negative 1 or negative 4. So there we go. That's the answer. This one, I'm not going to plug it in because I know it's going to be 0 over 0. If you plug in 0, 0 to the 4th is 0. 0 plus 0. Like it's all 0 over 0. It's a lot of red. Let me change to black. So I know it's going to be 0 over 0. So next I got to solve. I got to factor it. Now a lot of people have a hard time factoring this one. That's because they're overthinking it. Look what they have in common. An x squared. So when you factor this, it's just going to be x squared, 5x squared plus 8, x squared, 3x squared minus 16. Alright, so when you factor, you just get this. And now these cancel out. And now all you have is the limit as x approaches 0 of 5x squared plus 8 all over 3x squared minus 16. Plug in 0. So I plug in 0, this goes away. And all I get is 8 over negative 16 or negative 1/2. So that's how you generally do limits, right? You plug them in. If they work, great, you're done. If they don't work, if you get 0 over 0, which is the only thing we consider not working, then you have to fix it by factoring. So how do you find limits from a table? So what you do here is you're looking at your table and you just want to see where's it going towards. So in this case, we want the limit as x goes to 2 from the left. So this is my x. Here is 2. It's just like doing a graph. From the left means we're going this way. As I go this way, we'll have to your numbers. 5.1, 5.01, 5.001. Looks like it's going toward 5. So that'll be my answer. 2 from the right. So here's 2 again. We're coming from the right. We're coming from this direction. And what's happening to my numbers? 4.7, 4.89, 4.99. So look like it's getting close to 5. Is there a limit? Yeah, those two things match. So my limit's 5. Right? Anytime they match, that's your answer. If they don't match, it does not exist. So let's do the same thing down here. Now that we have the idea, limit as f of x as x approaches 2 from the left. So here's 2. From the left, looks like we're getting down to 3. Right, going down 3. From the right, so going this way, as you get closer from the right, look at your numbers, 8.3, 8.2, 8.1, you can get close to 8. Those do not match, so it does not exist. Limit to as x approaches infinity. So these are special. When there's a limit as x goes to infinity, those are horizontal asymptotes. So they follow the same rules of horizontal asymptotes. They're exactly the same thing. So if the top power is bigger than the bottom power, we got none. In that case, this would be infinity or negative infinity. If the bottom power is bigger than the top power, then we got 0. And if they're the same, you look at the ratio. So just like when we did horizontal asymptotes. So look at this one right here. Limit as x approaches infinity. So in this case, top power is bigger than the bottom power. But it actually does matter by how much. So if you only look at the highest powers here, you're going to get x to the 4th over x cubed. That's all we really care about. These reduce and you get x over 4. And then you kind of like plug in infinity. You don't actually plug in infinity, but that's the idea. You plug in infinity, you get infinity over 4. It's just infinity. Next one, only look at the highest powers again. What's my highest power on the top? If I multiply those, I'll get negative 2x squared. Look at the bottom. If I multiply these, I get x squared. So they're the same. So look at the ratio, right? Bottom equals top, same power. Look at the ratio. The ratio would give you negative 2 over 1 or just negative 2. I'm like circling. I don't know why I'm circling them. Next one. Symmetry is the first one. Top power. Ooh, I actually almost made a mistake. These are the same. So let's look at those two. So this is limit as x approaches infinity. When you look at the highest powers, 3x squared, 3x cubed over negative 2x cubed. They're the same, so you only look at the ratio. So 3 over negative 2, or negative 3 halves. So there we go. Next one. So it's a little tricky. So I have to rewrite it. That's x to the 1/4. Over here, all I care about is the highest power. So let's go with the x. So that's going to be x to the 1/2. Right, square root is just 1/2 power. That's 1/4 power. Which one's bigger? The bottom is. The bottom's like less small. So the bottom one's bigger. So remember how the bottom's bigger than the top? It's a 0. Bottom's growing faster than the top is. So you just get 0. Next one. Same thing. Bottom wins again. This is my favorite. 0. So that's what I'm going to watch out. Don't make the same mistake I almost made earlier. Look at the highest powers. So in this case, it's this guy and this guy. So we get a ratio again. So we're going to take the limit as x approaches. That's an L. Infinity of 3x squared over 2x squared. Right? Those are the same power. So you just look at the coefficients. So 3 halves. Negative 3 halves. So I'm going to go for the negative there. So there's the answer. Okay. Next one. Let's read a graph and do the limits from a graph. After this, we're going to answer questions from it. So first, limit as x approaches 0 of f of x. So as you get close to 0, now again, not both sides just 0. What's the limit? Well, 0 of all things. Right there. So the graph's going. Next one, limit as x approaches negative 2. So remember, here's my x. Where's negative 2 at? Right here. So what's the limit? Well, on this side you're going to infinity. On this side you're going to negative infinity. They're not matching. So it does not exist. Next one. Limit as x approaches negative 2 from the right. So here's negative 2. Remember this is left and this is right. We're coming from the right hand side. So as you're coming from the right hand side, where's your graph going? Negative infinity. Next, limit as x approaches -4. So here's -4. Now remember, the limit means both sides. So if I'm going from the left side, I get like -2. If I'm coming from the right side, I get like, what was that, 4? So they don't match again. So again, does not exist. Next question though. As x approaches -4 from the left. So here's -4. We want to come from the left side. So we're going to -2. Limit as x approaches 2, f of x. So here's 2. What's the limit? From the left side, it's 2. From the right side, it's 2. Remember, I don't care about this spot. That's a f of something. That's not a limit. Limit, what's it look like it's happening? Look, let's get it 2. F of 2, that's what we're talking about. F of 2 is a closed circle. So where's the closed circle at? Right there. So that would be 2, 3, 4, 5. Limit as x approaches infinity, so it's a little tricky. I don't think we've done that in a while. Infinity is over here. So what that means is as you're getting over there, what's your graph doing? Look at this graph. It looks like, see how it's stopped here by the dotted lines? So it's the highest it gets is 3. So we're going to go past that. Like you extend this graph, it's just going to keep on going to 3. Limit as x approaches negative infinity. Negative infinity is over here. But again, we want to see what your graph, the y value is when you're going this way. That's the whole idea of the limit, right? What's the y value when I do this? So as I get close to negative infinity, so here's my graph, negative infinity, where's it going? It's also going negative infinity. Here's it going down. Just like that. And the last one, limit as x approaches -6. So here's -6. Here's the graph. So what's the limit? Well, as you go from the left and you go right, you get that point right there. Right, both sides, left, coming from the left, coming from the right, you go up to the same spot, which is -4. And that's the picture. Okay, almost done. Now, in this one, we're going to draw our own graph. We're given some things, we have to draw our own picture. Now, there's actually lots of answers to this. I'm just going to draw one example we could draw, but there's lots of examples how you can do this. So that's the function with the domain of that. That's how it follows the following. The limit as x approaches 2 from the right is negative infinity. So here's 2. Now, 2 from the right is negative infinity. So as you come from the right, you should be going down to negative infinity. So it should look kind of like this. Now from there, how you want to finish it, whatever. I'm going to leave it like that for now because I want to figure out the rest and then kind of connect them all. Okay, next one. Limit as x approaches infinity is 0. So here's infinity. Right, and as you're going from, so as you're getting closer to infinity, you should only get to 0. There's like an asymptote over here at 0. So my graph here probably should look like this. Right, I'm not ever going to go past 0, and that's kind of a thing like that. So next, the limit as x approaches -3. So -3 is right here. So that's -3 is 1. So limit as x approaches -3 is 1. So lots of ways you can do this. For some reason, I always think of limit with the hole in it. So you can put at -3 at 1. There's a little open circle. That's the way I think about it. And I just got to fill out the rest. I can do anything I want. I can go like this, right? Doesn't tell me anything about this side. I just got to make sure I don't like go through it, and I don't make a not function. I don't go all the way across. So I can do anything I want. I can go up here like that. That works. That's totally fine. If you want, you could go down here and then go, I mean, you could go up or down, it doesn't really matter, like that. That totally works, right? There's no one right answer. You can make it a closed circle. I always think of a limit as open circles, but it could totally be a closed circle and just be like this. That works, right? So there's no, as long as it has a limit at -3, as long as the limit at -3 is 1, you're good. So lots of answers. And that's a worksheet.